What is nothing? Is it the complete absence of everything, or is it something in itself? If you close your eyes and imagine nothing, are you still imagining something? This question has confused the greatest thinkers in history, from ancient philosophers to modern scientists. For centuries, we have tried to explain what nothing really is. Some believed it was impossible, that nothing could ever exist. Others thought of it as an empty space, a void waiting to be filled. Today, physics tells us that even the emptiest parts of space are not truly empty. Tiny particles flicker in and out of existence, and energy flows where we expect silence. So does true nothingness even exist? This journey will take us through history. We'll see how different cultures, religions, and scientific discoveries have shaped our understanding of nothing. Along the way, we'll find a strange paradox. When we talk about nothing, it turns into something. Think about this. Imagine stepping into an empty room. There's no furniture, no decorations, just bare walls. You might think the room has nothing in it, but does it really? There's still air, light, and even the sound of your breathing. No matter how much we take away, something always seems to be there. So, if we can never truly experience nothing, does it exist at all? Or is nothing just an idea, a shadow of something we cannot fully grasp? So how did early humans think about nothing? Before humans had science or philosophy, they had experience. The earliest people did not think of nothing in an abstract way, as modern physicists or philosophers do. Instead, their understanding of nothing was deeply practical, shaped by survival. Imagine an early human standing in the cold night without fire, feeling the darkness close in. To them, nothing was the absence of light, warmth, and safety. A starving tribe would experience nothing as the absence of food. A dry riverbed would mean nothing in terms of water. These early ideas of nothing were not about deep philosophical questions, but about real-life needs, what was missing and what was necessary for survival. But even in these early times, people started wondering, if something can disappear, where does it go? If a person dies and their body remains, but their life is gone, what happens to them? Does death mean becoming nothing? These simple questions laid the foundation for how human beings would think about nothingness for thousands of years. Over time, early humans started to think about nothing in a deeper way, beyond just practical concerns. Nature played a big role in shaping their ideas. When people looked at the night sky, they saw stars and vast blackness. They wondered if this darkness was something in itself or just empty space. Different cultures had different views. Some thought the sky was a dome with stars, while others saw the darkness as an endless void. People also noticed that breath and wind were invisible. If something could move and have power but couldn't be seen, was it something or nothing? This led to the idea that even what seems like nothing might be filled with unseen forces like spirits or hidden energies. Dreams and shadows were also mysterious. When people closed their eyes and saw things that weren't physically there, did that mean dreams came from nothing? And shadows, were they real objects or just a form of nothingness attached to something real? These everyday experiences slowly transformed into deeper spiritual and philosophical ideas. Nothingness was no longer just about missing food or light. It became a concept tied to existence, non-existence, and the nature of reality itself. Since early humans lacked scientific explanations for the universe, they turned to myths to explain creation. One of the most common themes across different cultures was the idea that the world began from nothing, or rather, from some kind of primordial void. This void was not necessarily nothing in the modern sense, but rather a formless chaos from which everything emerged. Many ancient traditions have ideas about the void or nothingness. In Greek mythology, there was chaos before the gods existed. Chaos was a dark, swirling void that contained the potential for everything. From chaos came the first gods, the earth, and the sky. Chaos was both nothing and everything at the same time. In Norse mythology, there was Ginnungagap, a vast emptiness between the realms of fire and ice before the world was created. It was not just empty space, but a place of potential where forces met to create the first beings. This shows that nothingness in myths is often not pure absence, but a mysterious state filled with the potential for creation. In Chinese philosophy, Taoist thought also explores nothingness. The Tao, is described as something that cannot be named or fully understood, and from it, all things emerge. In Laozi's Tao Te Ching, the idea of the empty vessel is used as a metaphor. Emptiness is not useless, it is what allows things to function. This shows an early understanding that nothingness is not simply the absence of things, but something that can hold great power. To understand how different cultures viewed nothingness, let's look at their creation myths, which often start with a void. In Greek mythology, the universe began as a vast, shapeless void called chaos. It wasn't completely empty. It held the seeds of everything to come. From chaos emerged Gaia, earth Tartarus, the deep abyss, and eros, love. This shows that even in the absence of form, something can still exist. Hindu scriptures describe the beginning of the universe as a state where nothing and everything existed at once. The concept of Brahman represents a reality beyond existence and non-existence. According to the Rigveda's Nasadiya Sukta, before creation, there was only an endless, indescribable nothingness from which the cosmos arose. This challenges the idea that nothingness must mean absence. Instead, it can be a hidden reality beyond human understanding. In Norse mythology, before the world existed, there was Ginnungagap, a vast void between the realms of fire, Muspelheim, and ice, Niflheim. When these realms met in the emptiness, the heat melted the ice, creating the first giant and leading to the formation of the world. Ginnungagap was a space waiting to be filled, unlike the swirling Greek chaos. In the book of Genesis, before God created the heavens and the earth, the world was described as formless and empty. This doesn't mean absolute nothingness, but a chaotic, unformed state that needed divine order. Many religious traditions share the idea that nothingness is not completely empty, but requires structure. The earliest humans experienced nothingness in their daily lives, darkness, hunger, or absence. Over time, they began to see nothingness as more than just emptiness. Myths and religious texts describe the universe as emerging from a void, which was often filled with potential rather than absolute emptiness. This idea sets the stage for later philosophical and scientific debates. Can true nothingness exist, or is what we call nothing always something in disguise? From the first humans staring at the night sky to ancient myths of the void, the search for the meaning of nothing had only just begun. The ancient Greeks were among the first to seriously question the nature of nothingness in a logical and philosophical way. Instead of relying only on myths and religious stories, they sought to understand the world using reason. As they studied existence, motion, and space, they inevitably encountered a deep and puzzling question. Can nothing truly exist? Some argued that nothingness was impossible, while others believed that empty space, what we might now call a void, was a necessary part of reality. These debates laid the foundation for scientific and philosophical discussions about the nature of space, emptiness, and existence itself. One of the first Greek philosophers to tackle the concept of nothing was Parmenides of Elea. His ideas were radical and challenged the way people thought about reality. Parmenides argued that nothingness is impossible. His reasoning was simple but profound. If nothing truly existed, it would be something. But nothing cannot be something. Therefore, nothing does not exist. This may sound like wordplay, but Parmenides was making a serious claim about reality. He believed that only being, something that exists, is real. And non-being, nothingness, is not real and cannot even be properly thought about. Since Parmenides denied the existence of nothingness, he believed that the universe must be completely full, without any gaps, empty spaces, or voids. According to him, there is no true change in the world. Everything simply is. What people see as change is just an illusion. There is no space for things to move into because a true void does not exist. Parmenides' ideas were difficult for many people to accept. After all, we experience change every day. We see things grow, decay, and move. But his reasoning was so influential that later philosophers had to respond to it, either to defend or to challenge his claims. Parmenides' rejection of nothingness forced other philosophers to rethink their views. One important response came from Democritus. They introduced the idea that empty space, a void, must exist for movement and change to occur. Democritus and his teacher Leucippus developed atomism, the theory that everything in the universe is made up of tiny, indivisible atoms. These atoms are eternal, unbreakable, and constantly moving. They exist in empty space, a void that allows them to move freely and combine to form objects. This idea was revolutionary because it opposed Parmenides. Instead of a solid, unchanging universe, Democritus described a reality filled with small particles moving through vast, empty space. For Democritus, motion was essential to reality. He argued that if the universe were completely full, motion would be impossible because everything would be packed together. The only way for atoms to move is if there is nothingness between them, an empty void that allows for motion and rearrangement. Without the void, everything would be a single, solid block, and change could never happen. This was one of the first scientific arguments for the existence of a void. Unlike Parmenides, who thought nothingness was impossible, Democritus saw it as a real part of the physical world. His ideas were similar to modern physics, though he had no microscopes. He correctly imagined that matter was made of invisible particles and understood that space was necessary for movement. The debate over nothingness did not end with Democritus. Another great philosopher, Aristotle, had a different view. Aristotle rejected the idea of empty space. He believed that nature is continuous with no true gaps or voids. The universe is made of substances that are always connected in some way. Motion and change happen without needing a void. One thing pushes another, like a chain reaction. Aristotle's famous argument against the void is often summarized as, "Nature abhors a vacuum." He argued that if a true void existed, it would be impossible to explain how things move through it. For example, imagine a cup filled with water. If you try to remove the water quickly, the air immediately rushes in to fill the space. This suggests that nature does not allow empty space to remain. If an empty space ever appeared, nature would fill it as quickly as possible. This idea shaped scientific thought for centuries. Even though Aristotle did not have the tools to test his theories, his influence was so strong that many people believed a void was impossible for over 1,000 years. Aristotle expanded on his rejection of the void. He explained motion as a process where one object pushes another, rather than objects moving through empty space. He believed that everything in nature had a natural place. For example, heavy things like rocks naturally move downward, while fire moves upward. Since movement in his system depended on substances pushing or pulling each other, he thought that a completely empty void would make motion impossible. The debate between Parmenides, Democritus, and Aristotle shaped how humans thought about nothingness for centuries. Parmenides denied the existence of nothingness completely, arguing that the universe is a full, unchanging whole. Democritus introduced the idea of atoms and the void, which later inspired modern physics. Aristotle rejected the void, and his ideas influenced thinkers for over 1,000 years, becoming central to medieval and early scientific thought. They laid the groundwork for all later discussions about space, motion, and the fundamental nature of reality. As the ancient Greek debates over nothingness faded into history, a new force took center stage in the discussion: religion. The Middle Ages, roughly spanning from the 5th to the 15th century, were dominated by monotheistic faiths such as Christianity, Islam, and Judaism. Each of these religions brought new perspectives on nothingness, often tying it directly to the idea of God, creation, and the nature of existence. For ancient Greek thinkers, the question of nothingness was largely philosophical and scientific. They debated whether a true void could exist and what that would mean for the universe. But for medieval religious scholars, the question became deeply theological. If God is the creator of everything, did he create the universe from nothing? Or was there always something that existed alongside God? And if God is infinite, does that leave any room for a true void? These questions led to centuries of debate, influencing not only theology, but also the way people thought about science, space, and the very nature of reality. Monotheistic religions shaped the idea of nothingness in a unique way. Ancient Greek philosophers like Aristotle and Democritus viewed nothingness as a physical concept, debating whether the void existed in nature. With the rise of monotheistic religions, the focus shifted from nature to God. Instead of asking, "Can nothing exist?" medieval theologians asked, "Did God create the universe from nothing, or was there something before creation?" The Bible and the Quran do not explicitly discuss nothingness like Greek philosophers did. However, they both describe a time before creation, suggesting the universe did not always exist. Genesis Bible says, "In the beginning, God created the heavens and the earth." Quran says, "Do not the unbelievers see that the heavens and the earth were joined together as one unit before we clove them asunder?" These texts suggest that before creation, there was nothing except God. The idea that God created everything from nothing is called creation ex nihilo. This concept became a central doctrine in Christianity, Judaism, and Islam. It was a direct rejection of Greek and Roman ideas, which often assumed that matter was eternal. The belief in ex nihilo led to new theological debates, such as whether God exists in a void, if nothingness is simply the absence of God, and what it means for the nature of non-existence if God created everything from nothing. To explore these questions, we turn to one of the greatest Christian thinkers of the Middle Ages, St. Augustine. Augustine of Hippo was a very influential Christian theologian. Before Augustine, many people believed that God shaped the universe from pre-existing material, like a potter shapes clay. However, Augustine argued that this was incorrect. He said that God did not shape the universe. He created it out of nothing. If God created the universe from nothing, then nothingness is not a physical void. It is simply the state before existence. Augustine believed that nothingness is not a real thing, it is just the absence of God's creation. He also believed that time itself was created by God, meaning there was no before creation, only God's eternal presence. If the universe came from nothing, then everything depends entirely on God's will. This also means that matter and the physical world are not eternal. Only God is eternal. This idea reinforced the belief that there is no such thing as an independent void, because God's presence fills all things. While Augustine's ideas became central to Christian theology, Islamic scholars also grappled with these questions. One important figure in this debate was Al-Farabi. Al-Farabi was a Persian philosopher who combined Greek and Islamic thought. He built on Aristotle's ideas but reinterpreted them through an Islamic lens. Like Aristotle, he rejected the existence of a true void. However, he disagreed with Augustine's idea that nothing is simply the absence of creation. Instead, he suggested that nothingness has a kind of logical existence. It can be thought about, even if it does not exist physically. Another major Islamic philosopher, Avicenna, expanded on Al-Farabi's ideas. He argued that there are two types of existence: necessary existence, God, something that must exist; contingent existence, the universe, something that exists but could have not existed. According to Avicenna, the universe was possible, not necessary, meaning it was created by God. Before creation, only God existed, and there was no true void. One of the biggest theological problems of the Middle Ages was this: if God is infinite and present everywhere, is there any room for a true void? If a vacuum existed, wouldn't that mean there is a place where God is not? Many theologians, influenced by Augustine and Avicenna, concluded that a perfect void is impossible because God's presence fills everything. Because of the strong belief that voids could not exist, medieval scholars often rejected the idea of empty space in nature. This belief delayed scientific progress, as many scholars dismissed ideas like the vacuum, until later thinkers, such as Galileo and Newton, challenged these religious assumptions. Medieval religious thinkers redefined the idea of nothingness, not as a void, but as a state before creation. The belief that God created everything from nothing, ex nihilo, became a central idea in Christianity and Islam. Thinkers like Augustine, Al-Farabi, Avicenna, and Aquinas shaped centuries of thought about nothingness. Their ideas also delayed scientific acceptance of vacuums and empty space, a debate that would continue into the Renaissance. Thus, the battle between nothingness, God, and the void would continue for centuries until science challenged these theological ideas once again. For over 1,000 years, the idea of nothingness was largely shaped by religious and philosophical beliefs. During the Middle Ages, theologians and scholars had firmly rejected the idea of a true vacuum, following the teachings of Aristotle and Thomas Aquinas, who believed that nature abhors a vacuum. The idea that empty space could exist was seen as both scientifically impossible and theologically troubling. If God was everywhere, how could there be an empty void where he was not? But during the Renaissance, a period of immense intellectual rebirth, thinkers began questioning these long-held assumptions. Science started breaking free from religious doctrine, and new experiments challenged the belief that vacuums were impossible. One of the most important figures in the Renaissance was Galileo Galilei, the Italian astronomer, physicist, and mathematician who revolutionized scientific thought. Among his many discoveries, Galileo challenged Aristotle's claim that vacuums were impossible. Aristotle believed that all space must be filled with something and that a vacuum could never exist. He argued that if there were empty space, objects would have nothing to push against and therefore could not move. This idea was widely accepted for over 1,500 years. Galileo did not accept ideas without evidence. He believed that scientific truth should be based on experiments and observation, not just ancient philosophy. He argued that motion does not require a medium. An object could keep moving even in empty space, as there would be nothing to slow it down. This was a radical idea because it meant that Aristotle's theory of motion was wrong. Galileo studied the effects of air resistance and found that objects fall at the same rate regardless of their weight. He speculated that if all air were removed from a space, objects would fall at the same speed without resistance. This was an early hint that vacuums could exist. This laid the groundwork for later vacuum experiments by scientists like Evangelista Torricelli. Galileo's ideas challenged centuries of Aristotelian thought, opening the door for a new understanding of empty space. However, not everyone agreed with him. One of his contemporaries, René Descartes, strongly opposed the idea of a true vacuum. The French philosopher and mathematician René Descartes played a major role in shaping scientific thought. However, unlike Galileo, Descartes refused to accept that empty space could exist. Descartes believed that the universe was made up of one continuous substance, which he called plenum, Latin for fullness. According to him, there could be no such thing as an empty vacuum because all space must contain some form of matter, even if it was invisible. He argued that space was not separate from matter. Instead, space and matter were the same thing. Descartes proposed that the universe operates like a system of whirlpools or vortices, where matter constantly moves and fills all available space. He used this idea to explain gravity, planetary motion, and even light, suggesting that everything moves through an invisible fluid that fills the cosmos. This meant that there was no such thing as nothingness. Even seemingly empty space was filled with subtle matter. Descartes' rejection of the void was widely accepted at the time because it aligned with religious beliefs. A completely full universe suggested that God's presence was everywhere. His ideas influenced many scientists, but they would later be challenged by experimental evidence that proved vacuums could exist. One of the most important experiments in this regard was conducted by Evangelista Torricelli in 1643. Evangelista Torricelli, an Italian physicist and a student of Galileo. His famous experiment provided direct proof that empty space could exist, contradicting both Aristotle and Descartes. People had long observed that water pumps could pull water upward, but only to a certain height, about 10 meters. This puzzled scientists. If suction was caused by a vacuum, why couldn't the pump lift water higher? Torricelli realized that the limit of a pump's ability to lift water was not due to a vacuum being impossible, but because of air pressure. He filled a glass tube with mercury and inverted it into a dish of mercury. The mercury level dropped, leaving an empty space at the top of the tube. He concluded that this empty space was a vacuum, a region with no air or matter. His experiment was revolutionary because he showed that the air around us has weight and pushes down on liquids, which explains why pumps cannot lift water beyond a certain point. He proved that a vacuum could exist, contradicting centuries of Aristotle's teachings. His work led to the invention of the barometer, which measures atmospheric pressure. Torricelli's discovery changed science forever, leading to new research into air pressure, vacuums, and space. His findings also influenced Isaac Newton, who would take the idea of empty space even further. In the late 17th century, scientific thought was moving towards mechanical philosophy, the idea that the universe functions like a machine governed by laws. Isaac Newton played a key role in this shift. Newton believed in the existence of empty space, unlike Aristotle and Descartes, who thought vacuums didn't exist. He proposed that the universe was like a huge stage where objects like planets, stars, and atoms move freely through empty space. This idea was different from Descartes' universe, which rejected the notion of a void. Newton's laws of motion and gravity relied on the concept of objects moving freely in empty space. His first law of motion, inertia, explains that an object in motion will remain in motion unless acted upon by an external force. This means that in a vacuum, objects can move without slowing down. The second law, force and acceleration, explain that objects move because of force, not because they are pushed by an invisible substance. The third law, action and reaction, means that space itself does not push back. An object in empty space will move in a straight line unless something else affects it. Newton's acceptance of the void helped establish modern physics. The idea of space as an empty container became crucial for understanding motion, gravity, and later, Einstein's theory of relativity. The Renaissance changed the way people thought about nothingness. Galileo showed that motion didn't need a medium, challenging Aristotle's ideas. Descartes didn't believe in empty space and thought the universe had to be full. Torricelli's experiment proved that vacuums are real. Newton accepted the idea of the void, which helped modern physics take shape. This rediscovery of the void was one of the biggest scientific revolutions, proving that nothingness is real and is an essential part of understanding reality. For centuries, scientists and philosophers debated whether nothingness truly exists. The ancient Greeks, the medieval theologians, and the Renaissance scientists all tried to understand the nature of empty space. By the 17th century, Isaac Newton introduced the idea of absolute space, a vast, unchanging stage where objects moved according to the laws of motion and gravity. This concept dominated science for over 200 years. However, in the early 20th century, a revolution in physics changed everything. Albert Einstein's theory of relativity shattered Newton's idea of absolute space. Instead of being a fixed, empty container, space was revealed to be dynamic, flexible, and deeply connected to time. Even more surprisingly, modern discoveries have shown that what we once thought of as empty space is actually full of invisible forces, including dark energy and dark matter. For Isaac Newton, space was simple. He believed that space was like a vast, unchanging stage where objects move. This stage existed independently of the things within it, and even if you removed all matter, space would still exist as an absolute void. This idea was called absolute space, meaning space is a fixed, empty container stretching infinitely in all directions. Newton also believed in absolute time, where time flowed steadily and uniformly everywhere in the universe. For centuries, Newton's view made sense. His laws of motion and gravity explained how planets moved and how objects interacted. However, as scientists studied space, light, and motion more closely, they found problems with Newton's ideas. Then came Albert Einstein, who changed everything. Einstein's theory of relativity showed that space is not a fixed stage. It can stretch, bend, and ripple. Time is not absolute. It is linked to space, forming a single fabric called space-time. Gravity is not just a force pulling objects. It is the bending of space-time caused by massive objects. This meant that Newton's empty void did not exist. Space was no longer a passive backdrop. It was active and dynamic, making the concept of true nothingness even more complicated. One of the most mind-blowing ideas from Einstein's theory is that space itself can bend and curve. This was proven by multiple experiments. In the 1919 eclipse experiment, astronomers observed that light from distant stars bent around the sun during a solar eclipse, proving that space is not just an empty void. It can be shaped and distorted by gravity. In 2015, scientists detected gravitational waves, ripples in space-time caused by colliding black holes. This confirmed that space is not a rigid emptiness but a flexible fabric that can move and change. These discoveries challenge the idea of nothingness. If space can bend, stretch, and ripple, can it ever be considered truly empty? As scientists studied space more closely, they discovered that what we once thought was empty space is actually full of invisible forces. Two of the biggest mysteries in modern physics, dark matter and dark energy, explains that the vacuum is far from empty. Dark matter is the hidden mass of the universe. When astronomers observed galaxies, they found that they were rotating too fast. According to Newton's and Einstein's equations, they should have flown apart. This meant there had to be invisible matter providing extra gravity. Scientists called this mysterious substance dark matter, even though they can't see or detect it directly. It makes up about 27% of the universe, yet we still don't fully understand what it is. Dark energy is the force pulling the universe apart. In the 1990s, astronomers discovered that the universe was expanding faster and faster rather than slowing down. This meant there was some unknown force pushing galaxies apart. Scientists called this force dark energy, and it makes up 68% of the universe. Like dark matter, it is invisible, but its effects are everywhere. This means that what we once thought was empty space is actually filled with strange and powerful forces. The vacuum is not truly nothing. It contains energy, invisible matter, and even the ability to expand and change. Before Einstein's theory of relativity, most scientists thought space wasn't empty. Instead, they believed it was filled with an invisible substance called the ether. In the 19th century, scientists thought that light needed a medium to travel through, like sound waves need air or water. They imagined an invisible substance called the luminiferous ether filling all of space, which allowed light waves to travel through empty space. In 1887, Albert Michelson and Edward Morley set up an experiment to detect the ether. They believed that if the ether existed, Earth's movement through it would create a measurable effect on light waves. However, their experiment found nothing. Light moved at the same speed in all directions no matter how they measured it. This was one of the most important failures in science, proving that space was not filled with ether. The Michelson-Morley experiment paved the way for Einstein's theory of relativity. It showed that light does not need a medium to travel, it moves through space itself. This helped establish the idea that space is not a physical substance, but something that can bend and change according to Einstein's equations. Einstein's theory of relativity and modern discoveries have completely changed how we understand nothingness. Newton believed in absolute space, an empty stage where objects moved. However, Einstein proved that space is not fixed. It bends and stretches with gravity. Modern physics shows that space is filled with invisible forces like dark energy and dark matter. The Michelson-Morley experiment disproved the idea that space was filled with ether, leading to a new understanding of the vacuum. Instead of being a true nothing, space is a dynamic, active entity, one that is essential to the structure of the universe itself. This realization has led to even deeper questions. If space is not empty, what is it made of? And could nothingness ever truly exist? These mysteries continue to drive modern physics forward. showing that the quest to understand nothing is far from over. For thousands of years, people have debated the nature of nothingness. From the ancient Greeks, who argued whether a void could exist, to Einstein's revelation that space bends and stretches, our understanding of nothing has constantly evolved. But in the 20th century, an even more mind-blowing discovery emerged from the field of quantum mechanics. Empty space is not actually empty. Even in the most perfect vacuum, where there are no particles, no air, and no light, something is still happening. The universe is never completely still. At the heart of this discovery are concepts that seem almost magical. Heisenberg's uncertainty principle, which explains that true emptiness is impossible. Quantum field theory, which shows that even a vacuum contains invisible energy. Virtual particles, which constantly appear and disappear, popping in and out of existence from nothing. The Casimir effect, a bizarre experiment that proved empty space can generate force. These discoveries have completely changed the way scientists think about reality. One of the strangest ideas in quantum mechanics is Heisenberg's uncertainty principle, proposed by Werner Heisenberg in 1927. This principle explained that there's a fundamental limit to how precisely we can measure things at the smallest scales. In classical physics, if we know all the forces acting on an object, we can perfectly predict its future. But in quantum mechanics, some things can never be precisely known at the same time. Heisenberg showed that energy and time are linked by uncertainty. If you try to measure the exact energy of a system, you can't know how long that energy lasts. If you try to measure how long a system stays in a certain state, you can't know its exact energy. Because of this uncertainty, even in the emptiest possible space, there are tiny fluctuations in energy that we can never get rid of. This means that a perfect, motionless nothingness can never exist. Energy is always fluctuating, even in a vacuum. This discovery led to the next big idea, quantum field theory, which explains why the vacuum is never truly empty. In classical physics, a vacuum was thought to be completely empty, a space with nothing inside. Scientists once believed that if all matter, air, and radiation were removed, what remained would be a true void. However, quantum mechanics has revealed a very different reality. In the early 20th century, physicists discovered that particles are not just tiny objects moving through space. Instead, every type of particle is linked to an invisible energy field that fills the entire universe. This idea became the foundation of quantum field theory, which explains that reality is not made up of isolated particles, but rather interacting fields of energy. According to quantum field theory, even what appears to be empty space is actually a complex and dynamic structure. Surprisingly, even when no real particles are present, these quantum fields continue to vibrate and fluctuate. These energy fluctuations are incredibly small and unpredictable, but they never stop. They are happening everywhere, all the time. This means that what we once called a vacuum is not truly empty. Instead, it is filled with unseen energy and activity at the quantum level. One of the most important consequences of this is the concept of zero-point energy. This refers to the lowest possible energy state of a quantum field. Even in a vacuum, this energy remains, meaning that space itself can never be truly empty. This strange property of quantum fields leads to bizarre effects such as virtual particles briefly appearing and disappearing, seemingly from nothing. These discoveries have completely changed our understanding of empty space, proving that what we once thought of as nothing is actually full of energy and activity at the smallest scales. One of the strangest discoveries in quantum physics is that space is never truly empty. Even in a perfect vacuum, particles constantly appear and disappear. These particles are called virtual particles. Virtual particles are not real in the traditional sense. They pop into existence from the vacuum for a very short time and then disappear. Although they cannot be directly observed, their effects are measurable. They follow Heisenberg's uncertainty principle, which means that because energy fluctuates in empty space, pairs of particles and antiparticles can briefly appear from nothing. However, they disappear so quickly that they do not violate the laws of physics. Virtual particles might seem like an abstract concept, but they have real, measurable effects. They contribute to the force between charged particles, helping to explain how atoms hold together. They also cause tiny shifts in atomic energy levels, which was first observed in the Lamb shift experiment in 1947. Additionally, virtual particles might even be responsible for dark energy, which drives the expansion of the universe. One of the most fascinating experiments proving the reality of virtual particles is called the Casimir effect. Quantum mechanics has completely transformed our understanding of nothingness. What once seemed like empty space is actually a bubbling sea of energy and activity. Heisenberg's uncertainty principle proves that true nothingness is impossible. Energy always fluctuates, even in a vacuum. Quantum field theory shows that empty space is filled with invisible energy fields that shape reality. Virtual particles constantly pop in and out of existence, demonstrating that even the vacuum is full of motion. The Casimir effect proved that empty space can generate force, confirming that the vacuum is never truly empty. These discoveries have deep implications for our understanding of the universe. If a vacuum is not truly empty, then what is space really made of? Could we one day harness vacuum energy? And does this mean that nothing is just another way of describing something we don't yet fully understand? The search for the true nature of nothingness is far from over. Instead of being the absence of existence, quantum mechanics suggests that the vacuum is the foundation of reality itself. For centuries, scientists and philosophers debated whether nothingness could truly exist in the physical world. But the idea of nothing is not just about space, vacuums, or quantum fields. It is also deeply connected to human thoughts, emotions, and existence. What happens when a person feels that life has no meaning? What if the void is not in space but inside the human mind? This question became central to existentialist philosophy, a movement that explored human freedom, responsibility, and the search for meaning. Jean-Paul Sartre, one of the most influential existentialist thinkers, argued that humans are born into nothingness and must create meaning for themselves. Others, like nihilists, believe that life has no inherent purpose at all. Some, like absurdists, suggested that meaning might exist, but humans will never truly understand it. But despite these challenging ideas, many philosophers and psychologists have argued that humans can find meaning even in the face of nothingness. One of the most powerful examples of this comes from Viktor Frankl, a Holocaust survivor who wrote about how people could create purpose even in the darkest moments of life. Jean-Paul Sartre was a French philosopher who explored what it means to exist. In his famous book, Being and Nothingness, he argued that humans are thrown into existence without any built-in purpose. Unlike religious traditions that say humans are created for a divine reason, Sartre believed that we start as nothing and must create our own meaning. One of Sartre's most famous ideas is existence precedes essence. This means that people exist first and only later define what their life means. A chair, for example, has an essence before it exists. It is designed with a purpose in mind. But humans are not like chairs. We are born without a fixed purpose and must create our own identity and meaning through our choices and actions. Sartre argued that because there is no built-in meaning to life, humans are completely free to define their own purpose. But with this freedom comes responsibility. If there is no universal rulebook for life, then each person is responsible for their own choices. Many people find this idea frightening because it means that there is no external structure to rely on. We must face the emptiness and build something from it. According to Sartre, realizing that life has no predefined meaning can lead to a deep feeling of anxiety, which he called nausea. This feeling arises when a person recognizes that nothing is guiding them except their own decisions. However, Sartre saw this not as a reason for despair, but as an opportunity, a chance to embrace freedom and create something meaningful from nothingness. But Sartre's ideas were not the only perspective on nothingness. Other philosophers took his ideas in different directions, leading to two major schools of thought: nihilism and absurdism. Nihilism is the belief that life has no meaning, purpose, or value. This idea became popular through the writings of Friedrich Nietzsche, who famously said, "God is dead." Nietzsche believed that traditional religious values were losing their power and that people had to face the reality that there is no ultimate meaning in the universe. Nihilism can lead to deep despair, as it suggests that nothing we do truly matters. Absurdism, developed by Albert Camus, takes a different approach. Camus argued that life might have meaning, but humans can never fully understand it. This creates a constant struggle, or the absurd. Instead of falling into despair, Camus suggested that we should accept the absurdity of life and live fully despite it. His famous example is the myth of Sisyphus, a Greek legend about a man doomed to roll a boulder up a hill for eternity. Even though Sisyphus's task is meaningless, he can still choose to find joy in the struggle. This is Camus' way of embracing life's absurdity. While nihilism leads to emptiness and absurdism embraces the unknown, some thinkers believed that humans can create purpose even in the worst conditions. One of the most powerful examples of this is found in Viktor Frankl's story. Viktor Frankl was an Austrian psychiatrist and a Holocaust survivor. He was imprisoned in Nazi concentration camps, where he witnessed immense suffering, loss, and despair. Yet despite the horrors around him, Frankl found a way to hold on to meaning and purpose. In his book, Man's search for meaning. Frankl argues that even in the worst conditions, people can find meaning in their experiences. He observed that prisoners who had a sense of purpose through faith, love, or a personal goal were more likely to survive. He famously wrote, "Those who have a why to live can bear almost any how." Frankl developed a psychological approach called logotherapy, which focuses on finding meaning even in suffering. He believed that meaning could come from work, having a goal or creative purpose, love, relationships and connections with others, and suffering, finding strength and personal growth in hardships. Frankl's experiences show that even in the most extreme void, complete loss, suffering, and despair, people can still create meaning. His ideas contrast with nihilism, which suggests that nothing matters. Instead, Frankl argued that we must actively shape our own meaning in life. Sartre argued that life has no built-in purpose, but we have the freedom to create our own. Nihilists saw nothingness as a reason for despair, while absurdists accepted the struggle between meaning and meaninglessness. Viktor Frankl showed that even in the worst suffering, meaning can be found through purpose, love, and growth. The psychological void, the feeling of emptiness or lack of meaning, can be overwhelming, but it is also an opportunity. Instead of being a terrifying absence, nothingness can be a blank canvas on which we create our own meaning. In the end, the void inside us is not a prison, it is a space of possibility waiting to be filled. For much of Western history, nothingness has been seen as an absence, something missing, a void that lacks meaning or existence. But in Buddhist philosophy, nothingness takes on a very different meaning. Instead of being a lack of something, it is understood as interdependence, a concept that connects all things rather than separates them. This idea is best expressed in Śūnyatā, often translated as emptiness. But in Buddhism, emptiness does not mean nothingness in the way we usually think of it. Instead, it refers to the idea that everything is interconnected and lacks a fixed, independent existence. In other words, nothing exists by itself. Everything depends on something else. This concept is at the heart of the middle way, a path that avoids the extremes of eternalism, the belief that things exist permanently, and nihilism, the belief that nothing exists at all. Śūnyatā is a deep and transformative idea, leading to enlightenment by helping people let go of attachment to fixed identities and illusions. One of the most famous expressions of this idea comes from the Heart Sutra, which states, "Form is emptiness, emptiness is form." A simple way to understand this is by looking at a wave in the ocean. A wave is real, but it does not exist separately from the ocean. If you try to separate the wave from the water, it disappears. Similarly, nothing in life exists independently. It all arises from conditions and relationships. This is what Buddhist philosophy means by emptiness. Things are empty of independent existence, but they are still part of a greater interconnected whole. The idea of Śūnyatā is closely connected to dependent origination, one of the core teachings of the Buddha. This teaches that everything arises because of conditions. Nothing has an independent, unchanging existence. For example, a tree does not exist by itself. It depends on soil, water, sunlight, air, and time to grow. Similarly, a person does not exist independently. They are shaped by family, society, experiences, and relationships. This means that nothing exists on its own. Everything is part of a vast network of causes and conditions. In Buddhism, the idea of a self is an illusion. People often think of themselves as having a fixed identity. I am this person. I have always been this way. But according to Śūnyatā, the self is constantly changing. It is just a collection of thoughts, emotions, experiences, and body processes. Just like a wave in the ocean, a self appears because of conditions and changes from moment to moment. This realization is central to Buddhist practice. Understanding emptiness helps people let go of attachment to a fixed self and live with greater peace and flexibility. Before becoming the Buddha, Siddhartha Gautama lived in two extremes, a life of luxury and indulgence as a prince, and a life of severe self-denial as an ascetic. He discovered that neither extreme led to true understanding. Instead, he taught the middle way, a balanced path between excess and extreme denial. Many people suffer because they cling to things as if they are permanent, but everything changes. Others fall into nihilism, thinking nothing matters at all. The middle way shows that both views are incorrect. Things exist, but not independently or permanently. A relationship exists, but it is not fixed. It changes based on the actions of both people. A problem exists, but it is not permanent. Solutions can arise from new conditions. Life exists, but it is not an unchanging identity. It is a flow of experiences. By realizing that everything is interconnected and ever-changing, people can let go of suffering caused by attachment, avoid falling into despair or nihilism, and find peace in the reality of change and interdependence. This understanding of emptiness helps reduce fear, anxiety, and suffering. It teaches that nothing is isolated and change is a natural part of life. One of the most famous Buddhist scriptures that explain emptiness is the Heart Sutra. It contains the powerful phrase, "Form is emptiness, emptiness is form." What does this mean? Form means the physical world, the things we can see and touch. Emptiness means things have no independent, unchanging existence. These two ideas are not separate. They are the same truth. For example, a chair exists but only because of wood, tools, and a carpenter. It has no independent existence. A person exists, but only because of parents, food, air, and experiences. They are not separate from these conditions. Therefore, form is emptiness. Everything depends on something else. And emptiness is form. Things still exist, but not independently. The Heart Sutra teaches that understanding emptiness frees the mind from suffering. When people realize that things are not permanent and independent, they stop clinging to them. This leads to wisdom and peace, because nothing is fixed, everything is possible. When people realize that nothing exists on its own, they become more compassionate, because everyone and everything is connected. They become less afraid of change, because change is the nature of reality. They let go of rigid thinking, because no idea, belief, or identity is fixed forever. By deeply understanding form is emptiness, emptiness is form, people can move beyond suffering and live with greater wisdom, peace, and openness. The Buddhist concept of emptiness is not about nothingness in the way Western thought often describes it. Instead, it is about interdependence, the understanding that everything exists because of relationships and conditions. Nothing has a fixed, independent existence. Everything is connected and always changing. The middle way teaches that by embracing emptiness, people can avoid suffering and find balance. The Heart Sutra reminds us that form and emptiness are the same. Once we understand this, we are free to live with wisdom and compassion. Instead of seeing emptiness as a void, Buddhism teaches that it is a path to freedom. When people stop clinging to fixed identities, fears, and desires, they realize that the world is open and full of possibilities. For centuries, humans have wondered whether it is possible to create or find a place of absolute nothingness, a perfect vacuum where no matter, energy, or forces exist. In ancient times, philosophers debated whether a vacuum could even exist, while in the modern age, scientists have pushed the boundaries of technology to remove all particles and energy from space. Yet the more we explore, the more we realize that achieving perfect nothingness is far more difficult than we ever imagined. Today, some of the most advanced experiments, conducted by NASA, the Large Hadron Collider, and space telescopes, have revealed that even in the emptiest parts of the universe, something is always there. Whether it is ghostly quantum fluctuations, dark energy, or the fabric of space-time itself, modern physics suggests that a true vacuum, a place of absolute nothingness, might be impossible to achieve. Can we ever create perfect nothingness? For much of history, people believed that a perfect vacuum, a space completely empty of everything, was either impossible or unnatural. Aristotle argued that nature abhors a vacuum, and for centuries, scientists believed that empty space simply could not exist. But in the last few hundred years, humans have built powerful vacuum chambers and explored the emptiest regions of space, attempting to find out whether absolute nothingness can be created. Creating a vacuum on Earth involves using vacuum pumps to remove air and particles from a sealed chamber, resulting in a low-pressure environment. Some of the best vacuum chambers, like those at NASA, can eliminate over 99.999% of particles, making them among the emptiest spaces on Earth. However, even these extreme vacuums contain tiny amounts of gas, radiation, and energy. Quantum mechanics reveals that even in a vacuum, particles constantly appear and disappear. This means that even if we remove all the air, atoms, and radiation, we cannot eliminate the fundamental quantum energy present in space, known as zero-point energy. Another approach to removing energy from a system is by cooling it to absolute zero, which is minus 273 degrees Celsius or 0 Kelvin. At this temperature, all atomic motion theoretically stops. However, experiments have shown that even at absolute zero, quantum energy fluctuations still exist. This means that creating perfect nothingness is incredibly challenging, even under the best conditions. The idea of achieving a perfect vacuum, even in space, remains an elusive goal. NASA has created some of the largest and most advanced vacuum chambers on Earth to test spacecraft in conditions similar to outer space. One of the most well-known vacuum chambers is the Space Power Facility at NASA's Glenn Research Center, which is the largest vacuum chamber in the world. It can simulate the vacuum of space by removing nearly all air and particles, allowing scientists to test how satellites and spacecraft behave in extreme conditions. In 2018, NASA launched the Cold Atom Laboratory to the International Space Station. This experiment cooled atoms to 1/10,000,000th of a degree above absolute zero, which is the coldest temperature ever achieved in space. Scientists hoped that by reaching such extreme temperatures, they could observe quantum behaviors that might reveal more about the nature of the vacuum. Despite these near-perfect vacuum conditions, space is never truly empty. It is still filled with background radiation, dark energy, and quantum fluctuations. NASA's experiments have shown that a true, absolute vacuum may not exist, even in the emptiest parts of the universe. One of the greatest mysteries in cosmology is whether the universe has an edge, and if it does, what lies beyond it? Astronomers have discovered that the universe is expanding at an accelerating rate, driven by dark energy, a mysterious force that makes up about 68% of the universe. This raises the question, if the universe is expanding, does that mean there is an edge where it ends and emptiness begins? There are a few possibilities. The universe may never end and could expand forever without ever reaching a boundary. Another possibility is that beyond the observable universe, there could be a region of absolute nothingness, but this is purely theoretical. Some theories also suggest that our universe is just one of many, and beyond our cosmic horizon, there could be other universes. One of the most important places where scientists study vacuums is the Large Hadron Collider, the world's most powerful particle accelerator, located at CERN in Switzerland. The LHC uses vacuum tubes that are emptier than space itself, removing almost all air and particles. These tubes allow protons to accelerate near the speed of light without colliding with stray atoms. The LHC creates conditions similar to the early universe, helping scientists study fundamental forces and particles. In 2012, the LHC discovered the Higgs boson, a particle that helps explain how mass exists in the universe. This discovery showed that even in a vacuum, quantum fields exist that give particles their properties. LHC experiments have reinforced the idea that the vacuum is never truly empty. Even when all matter is removed, the Higgs field, quantum fluctuations, and virtual particles continue to exist. This confirms what quantum mechanics has long suggested. Nothingness is not real. Space is always full of invisible forces and energy. The quest to find or create a perfect vacuum has led to incredible scientific discoveries. NASA's vacuum chambers and space experiments have shown that even the emptiest regions of space contain energy and quantum activity. The expansion of the universe suggests that there may never be an absolute edge beyond which nothing exists. The Large Hadron Collider has confirmed that even in extreme vacuums, quantum fields remain active, making absolute nothingness impossible. Instead of finding true nothingness, scientists have discovered that the vacuum is a dynamic, active part of the universe, filled with quantum fluctuations, dark energy, and fundamental forces. The search for a true void continues, but the evidence so far suggests that absolute nothingness may not exist at all. Instead of being empty, space itself may be the foundation of all reality. For billions of years, the universe has been expanding, evolving, and forming new structures. Stars are born, planets form, and galaxies swirl across space. But what will happen in the far future? Will the universe continue forever, or will it eventually fade into nothingness? If everything ends, does that mean we are left with a state of true nothing, or could something new emerge? Scientists have developed different theories about how the universe might end. Some predict that the universe will expand forever, eventually becoming cold and lifeless in a scenario called heat death. Others believe the universe might collapse back in on itself, leading to a possible rebirth. There are also ideas that suggest a violent tearing apart of space itself, destroying everything. However, there is still much we do not know. Could new physics change our understanding of nothingness? Could something exist beyond what we now call nothing? And does an ending mean a complete disappearance, or just another transformation? These are the profound questions that scientists and philosophers continue to explore. The heat death of the universe is a concept that describes the universe's gradual journey toward emptiness. Since the Big Bang, the universe has been expanding, causing galaxies to drift apart. In 1929, Edwin Hubble observed that distant galaxies were moving away from us, proving this expansion. Scientists later discovered that the expansion is speeding up, driven by a mysterious force called dark energy. If this continues, the universe will keep expanding forever, becoming colder and emptier over time. Heat death refers to the idea that eventually all energy in the universe will be evenly spread out, making any useful activity impossible. Currently, energy moves from hot places to cold places, allowing stars to shine, planets to form, and life to exist. However, over trillions of years, stars will burn out, galaxies will drift apart, and black holes will disappear. In the final stage, everything will be at the same temperature, meaning no energy can flow and no work can be done. This results in a dead universe with no stars, no planets, and no movement, just vast, cold emptiness. Even in a universe where everything has faded, quantum physics suggests that true nothingness is impossible. Even if all matter disappears, quantum fluctuations, which are tiny bursts of energy appearing and disappearing, may continue in the vacuum of space. Some theories suggest that these fluctuations could eventually trigger a new Big Bang, restarting the cycle. While the universe may reach a state of extreme emptiness, it may never reach true nothingness. While current scientific theories suggest that the universe is heading toward emptiness, new discoveries could change this view. Dark energy is the force driving the universe's expansion, but scientists still don't fully understand what it is. If dark energy changes over time, it could cause unexpected effects, possibly preventing heat death or leading to a completely different fate. Some theories suggest dark energy could reverse or decay, causing the universe to collapse instead of expand. Quantum mechanics shows that particles can appear from nothing. A vacuum is never truly empty. If quantum effects continue even after heat death, new structures might form in the far future. Some scientists believe that quantum physics could allow universes to arise from nothing, suggesting that even after an end, something new may begin. Some cosmologists believe our universe is just one of many, part of a larger multiverse. If this is true, even if our universe reaches an end, others may continue to exist. Some theories suggest new universes could be born from the remains of old ones, preventing true nothingness from ever occurring. So while today's physics suggests an eventual end, it is possible that new discoveries could change this view entirely. Beyond science, the idea of absolute nothingness raises deep philosophical questions. If we define nothing as a complete absence of everything, no space, no time, no energy, then how could we ever observe it? Every time we think about nothing, we are making it something in our minds. Some philosophers argue that nothing is just an idea, not something that can actually exist in reality. Some Eastern philosophies, like Buddhism, teach that emptiness is not a final state, but rather a condition for transformation. Instead of seeing nothing as an end, it can be viewed as a state of potential where something new can emerge. This aligns with some modern physics ideas, suggesting that even the end of the universe might not be truly final. The idea of nothingness can be unsettling because humans naturally search for meaning and purpose. The thought of a universe without life, thought, or existence raises existential questions about why anything exists at all. Some thinkers, like Jean-Paul Sartre, argued that we must create meaning in a universe that does not provide it for us. The ultimate question remains, even if everything fades away, does that mean nothing remains? Or is there always something beyond? Scientists have proposed different ways the universe might end. Two of the most dramatic possibilities are the Big Rip and the Big Crunch. If dark energy continues to accelerate the expansion of the universe, it could reach a point where even atoms are torn apart. In this scenario, galaxies will separate, then stars, then planets, and eventually even molecules and atoms will disintegrate. Space itself will stretch infinitely until nothing is left, just a vast emptiness. This could happen in tens of billions of years, meaning our universe might end not in stillness, but in violent destruction. If dark energy weakens over time, the universe's expansion could slow down and reverse. Gravity would pull everything back together, causing galaxies, stars, and planets to crash into each other. Eventually, everything would be compressed into a single dense point, possibly leading to a new Big Bang. This theory suggests that the universe might be cyclical, constantly dying and being reborn. Which scenario will happen? Scientists are still trying to find out, but both suggest that the universe might not truly disappear. Instead, it could transform into something new. From the earliest myths to the latest scientific discoveries, the idea of nothing has fascinated and confused us. Ancient philosophers debated whether a true void could exist, while religious thinkers saw nothingness as the state before creation. Scientists once believed in empty space, but later discovered that even the vacuum is full of energy and hidden forces. We have explored the nature of nothing from many angles: philosophy, physics, religion, and human psychology. Yet the question remains unanswered. Does true nothingness exist? Every time we think we are close to defining it, something unexpected appears. Quantum fields, virtual particles, or even the possibility of multiple universes. Perhaps nothing is not an actual state, but a concept, something that only exists in our minds. Maybe the reason we struggle to define nothingness is that it is simply impossible for nature to be truly empty. Instead of a final absence, maybe nothing is just another way of describing something we don't yet understand. And so the search continues. Even as we try to grasp nothing, we keep finding something.